we're talking about complex numbers, that's something we're used to thinking it has an I in it. So we see a lot of imaginary numbers. Remember, with your imaginary numbers, I squared is equal to negative 1. So that means I is what? The square root of negative 1. So with an imaginary number, I is equal to the square root of negative 1. A complex number is anything of the form a plus bi. Okay, we call a the real part because it doesn't have an I with it. B is the imaginary part because it has the I. This is standard form, so anytime I do something with imaginary numbers, I will expect you to write your answer in a plus bi form. So keep it in this order, please. All right. We can classify our complex numbers. So, in general, complex, we said, is anything of the form a plus bi. If it's a real number, that means you don't have an imaginary part. So it's just like 5, negative 6, 7. The b is a 0 in those cases. If it is pure imaginary, then we don't have a real part. So it might be 5i, negative 6i. It's a single term, but the real part was 0. If it's not real complex, it has both parts. So it's the two terms, 3 minus 4i. Negative 2 plus 5i. It has both pieces to it. So first thing I want to do is just classify. We don't use this a ton. It's not like we're going to spend a ton of time classifying our numbers, but just so you're kind of familiar with all the different forms we might see. So if I just said 13i, what kind of number is that? And I said use all that apply in my directions, so we can call it real, complex, pure imaginary, non-real complex. This is also a complex number. All of these are going to be complex numbers. We're also just giving them a specific version. 5 plus I, what would that be? Non-real complex. And it's still a complex number. What about pi? Does it have an I with it? No, so it has to be a real number. And it is complex. When we see I start coming into our problem, it happens when we have negatives under a square root. So you guys remember, if you have a square root of negative 5, okay, a way to think about that is the same as the square root of 5 times the square root of negative 1. And the definition, square root of negative 1 is equal to I. I think in Algebra 2, she usually had you write it as I radical 5. So either one is okay. So if I just gave you the square root of negative 1, what's that called? I. What's the square root of negative 16? 4i. Okay, square root of negative 8. Yes. We have to think about 8 can be broken into a 4 and a 2. Square root of 4 is 2. We also take out an I because of the negative. And we still have a square root of 2. So I always want our radicals in lowest form. Any questions so far? When you are dealing with negatives under your radical, it is very important to pull out the I before you work with it. If I gave you the square root of negative 4 times the square root of negative 9, if you just multiplied those, you would get the square root of positive 36, which is 6, right? But what is the square root of negative 4? What's the square root of negative 9? If you multiply that, you get 6i squared. But what is I squared equal to? And the true answer is negative 6. But if you fail to pull out those i's, you will miss that. So make sure simplify the I first, especially when multiplying. Okay. Let's do some problems. Square root of negative 7 times the square root of negative 7. How would I write that? We don't know the square root of 7, but we can take out an I from each. When I multiply, what do we get? I squared radical 49. I squared is square root of 49, so we get a negative 7. B. So if we take out an I, you have I radical 20 over I radical 2. What happens to your i's? They cancel. If both of these numbers are under a radical, it's actually illegal just to go ahead and divide. You don't have to reduce the radicals first. So our answer would still be under the square root. What is 20 divided by 2? 10. So we just get a square root of 10 for that. Am I going too fast? Do you guys remember any of this stuff? Let's talk about some operations with i's. Adding, subtracting, multiplying. Adding and subtracting, the I just kind of works like an X. You're combining like terms. I do want your answer to be written in standard form, so A plus BI at the end. So if we add our real numbers, 3 plus negative 2, 1, plus the imaginary, 5i plus 3i, so we get 1 plus 8i. How do we subtract? Distribute the negative. Yep, change that to a plus, take our negative through, and then it's just an addition column. 6 plus negative 3, 4i, and negative 6i. How do we multiply? We have to distribute, FOIL. Multiply first. We get 10 plus 35i plus 6i plus 21i squared. Combine like terms, 35i plus 6i. What is 21i squared? Then add like terms, remember a plus bi, so 10 plus negative 21 is negative 11 plus 41i. sometimes we might have higher powers of I, and we want to simplify that as much as we can. We don't want to see an I to the 15. And what we have to remember is that every time we get two i's, when you have an I squared, it turns into what? Negative 1. So the question is, if I have 15, how many groups of 2 can we form? Okay. So I could think this is like I squared 7 times. Are there any left? Yes. So there is 1 I left over. And this is equivalent. 2 times 7 is 14, plus 1 is 15, so I'm just rewriting it. What is I squared equal to? What is negative 1 to the 7th power? Negative 1. If it's an odd power, you'll get negative 1. If it's an even power, it'll be positive 1. So I have negative 1 times I, negative I. You guys try B. So how did you write it? If you have 22, that's 11 groups of 2, none left over. I squared is negative 1, and negative 1 to the 11th is negative 1. Right. Do we need more problems like this? Okay. 2 last things I want to talk about dealing with i's. The first is if I have a quotient, how would I write that in standard form? So, standard form, a plus bi. The I can't be on the denominator. Kind of like with radicals, you can't leave the radical on the denominator. Let's do b first. What could I do on part b? If I take top and bottom times I, as long as you do the same thing on top and bottom, it doesn't change your problem. I get 3i over I squared. But I squared is, and 3i divided by negative 1 is negative 3i. So if it's just a single I on the denominator, we can multiply by it. Now if I look at a, if I multiply by I would have to distribute. So the bottom would become 5i minus I squared. Does that help me? No, it just shifted the term that I showed up in. What could we do instead? You guys, just kind of like with radicals, you want to multiply by the conjugate. Remember, conjugate is the same thing, but with a different sign in the middle. So we're going to take top and bottom by 5 plus I. So on top we FOIL. We get 15 plus 3i and plus 10i would be 13i plus 2i squared. On the bottom, if we FOIL, we get 25 plus 5i and minus 5i. What happens? It's canceled. That's why we do the conjugate, so those terms cancel. Minus I squared. On top, 15 plus 13i. 2i squared is equal to 2. On the bottom, we have 25 minus I squared. Becomes plus 1, so 26. We get 13 13i over 26. Technically, is that standard form a plus bi? Not really, because it's all mushed in one fraction, but we can break it apart. If you just think of each one being over the denominator, 13 over 26 is 1/2. So 1/2 plus 1/2 I, that's equivalent, but now it's broken apart, so it's in the actual standard form. Any questions there? Last ones, these are some that we will see later on when we deal with quadratics. Remember doing the quadratic formula? Sometimes you'd end up with negatives under your radical. So I just want to practice, how do we simplify something like this? So we have a -8 plus, what would I have to do with this square root? We have to break it down. We have to take out an I because of the negative. So what perfect square goes into 128? 64 and 2. Square root of 64 is 8, so this is 8i radical 2 over 4. So we could break it apart, just like each one over the denominator. We get -2 plus 2i radical 2. All right. Do we need to do B? You guys feel okay with this stuff? So you have some time now. I want you to work on homework. If you are struggling with word problems and have some questions, we can answer those now. I printed this on your paper as well. It's like 12 problems, so not too much.